So, namaste everyone, this is Srikanth and here we have another problem from the same paper. The previous problem was covered in another video, the link to which you can find in the description below, along with more links to this series of videos that I'm making on solving previous papers of Osmania University. So here we have the question. We have a crate held in equilibrium by two cables as shown. So now equilibrium, the sentence itself means that the resultant is zero. Fine. And we have been provided with the tension in the cable B. So cable B has a tension of 300 newtons that has been given to us. And he's asking us to find the weight of the crate. So this is the weight we have been asked to find. So now, because this is a problem of equilibrium, we will have to draw something called the free body diagram. Fine. So free body diagram, what we do is we just replace whatever contact points are there. All the contact points, we have to replace them with their equivalent forces. Fine. So this is our free body diagram. We have removed the contact points, this contact point, this, as well as the weight W. And now we'll have to replace them with their forces. Fine. So because these two are strings, A and B both are strings, so there will be tension acting in both the strings, and tension we know that it always pulls away from the point. So the tension in B has been given as 300. Tension in A, it's unknown. We don't need it actually. And this here is W. So W is what we are supposed to find in this particular problem. So this problem can be very easily solved using the Lami's theorem, since the problem covers all the conditions for the Lami's theorem. So in Lami's theorem can be applied to only three forces which are coplanar and which are in equilibrium. The resultant has to be zero, and we can apply the Lami's theorem over there. Fine. So since here we can see in the problem we have exactly three forces, and they're of course coplanar, and they are held in equilibrium, which means they satisfy all the conditions required for applying the Lami's theorem. So now Lami's theorem itself, what it says is for this set of forces, which are exactly three forces which are in equilibrium, coplanar, for these forces, each force divided by the sine of angle between the other two forces, that remains constant. So if we take the force A divided by the angle between other two forces, that is W and B, so that we know it's going to be 90 plus 30, that's 120. Fine. So A divided by sine of 120, this is going to be constant, which means if we take up B force, B divided by the angle between the other two forces, so this of course will be 90 plus 60, that is 150. So sine of 150. Fine. This will also remain constant. So the constant, which is this, will also be same as the constant, which is this. So that means they are both going to be equal. And the same principle can be applied for the other force, the last force, that is W. So W divided by the sine of angle between the other two forces, which is this. So now we can see this this angle over here is straight angle, that is 180. And from that we are subtracting the other two forces. So that gives us 90 degrees. That gives us 90 degrees. So W by 90 degrees. Fine. So sine of 90 degrees just becomes 1, and we just have to take up these two formulae because we are interested in B. We are interested in W, and we have been given the value of B. A is not concerned. So we just get W equals B, that is 300 divided by sine of 150. Let's take up and solve it. So we have 300 divided by 150 sine of this angle. So we get 600. So the value of W is 600 newtons. So this is our answer. So thanks for watching this video. If you want more videos like this, and if you have any doubts with this particular video, you can just let me know in the comments. And if you want me to solve more problems like this, you can also put the question over there, and in future I'll try to solve that. Thank you.